Hello everyone, my name is Yash Patel and this is my Astronomy 101 final project. My project is based on black holes and some myths surrounding their nature. Now black holes are beautiful and attractive, and by attractive I mean gravitationally attractive. Look at this cool animation to see what happens when you get too close to a black hole. Everything falls into it. Well, misconception and myths. Some misconceptions around black holes are shown on your screen right now, and reference to these misconceptions have also been provided at the end of this video. Now, a brief introduction on what is a black hole. A black hole is a cosmic entity with an immense gravitational pull, and it is not to be confused with its name. It's neither black nor a hole. They are just huge concentrations of matter that are so tightly packed that beyond its event horizon nothing can escape. Not even light can escape a black hole's gravitational pull. So the question definitely arises, like, how are they formed? So when supermassive stars collapse upon themselves at the end of their lives, they create entities that have the capacity to pull everything that passes close to them, even light. Now, for an example, if you want to make our sun, which is an M-type star, into a black hole, you need to shrink its size down to a penny while making sure that the mass still remains the same. So the mass of the entire sun and the size of a penny, so that's too dense. So these entities can vary in size from a few kilometers with a couple of solar masses up to supermassive galaxy eaters that can go up to billions of solar masses, such as the TUN 618 or the Sagittarius A star. Now think of it this way. Anything that gets too dense and heavy for its own size can create its gravitational pull, just like Peter Griffin from Family Guy. He has his own gravitational pull at the moment. Alright, now the anatomy of a black hole. Black hole has few distinctive features. Now the first one is an accretion disk, which is a hot disk of gas orbiting the black hole, and it is the main source of light. This is called the Doppler beaming, which is an effect that causes the accretion disk to brighten where it spins towards us and to dim where it spins away. This region is called the corona. They are the hot clouds extending above and below the disk as well. This region is called the event horizon. It is the boundary where the velocity needed to escape the black hole equals to the speed of light. The event horizon shadow is a dark zone roughly twice as big as the black hole's event horizon. This is called a photon sphere, and they are the thin rings of light appearing at the edge of the event horizon shadow. And this is the singularity, which is a theoretical point at the very center of a black hole where matter is crushed into infinite density. So now moving on to the next slide, which is light and escape velocity. You see your hand because the light is reflected from it, and anything is visible because of the reflection of light. Now black holes are so strong that you are not able to see them with a naked eye. So now think of it this way. When you throw a ball at a great speed, so fast that it escapes the gravitational pull of our planet, that velocity that the ball reached is called the escape velocity. Now to escape, the black hole's escape velocity is greater than the speed of light because of its immense dense mass. Now the question would arise, why was Christopher Nolan's black hole in the movie Interstellar luminous? Well, he did show us the first visual representation of a black hole, and the question is, why was it illuminated? It's because if you see this illustration, you can see that a star on the left hand side is venturing too close to the event horizon of a black hole. So now the black hole is slowly and gradually eating the star away. That dust and that light near the accretion disk of the black hole is what's creating the black hole luminous. This region is called the particle jets, where particles are thrown at infinitely high speeds, like at the speed of light. Now some bizarre facts about the black hole. So now they can help us understand the gravitational microlensing, just like this. The second is spaghettification. If you are supposed to fall into a black hole with feet first, you will be stretched. Some black holes spin at high speeds, causing the surrounding space-time to bend due to its high gravitational pull, like this. And there are supermassive black holes at the center of every galaxy. We also have one at our center of our galaxy, Milky Way, that is called Sagittarius A. And then there's Hawking radiation that says that eventually all black holes would come to an end. And because of the nature of the black holes, there is a theory of time dilation that is seen in the movie Interstellar. Cooper and Dr. Brandt, they did not age a year, while their teammate aged 23 years. Black hole mergers are events when two massive black holes collide and combine with each other. They send ripples around the space-time continuum. It looks something like this in this illustration. And this is the first ever recorded image of a black hole that was captured in 2020. That is this image is at the center of our galaxy Milky Way. So it was currently eating a star. That's why you can see luminous light around the black hole, and its name is Sagittarius A. It's roughly around 26,000 light years from Earth. And here are the references. And finally, thank you for watching this video.